Right, hello. So we should now have just gone live. My name is Joe Stevens from Darwin Recruitment. I'm one of the JavaScript recruiters for the German market here. Today, we are discussing the topic of whether artificial intelligence can replace front-end developers. And then we'll also move on to some other topics around the uses of artificial intelligence, challenges, etc. So with us today, we have Charles, who is the co-founder of an AI-driven startup in Berlin called Bunch.ai. And also have Francisco from Move Digital, Zurich Cantonal Bank, Education First. These are some of the businesses he's worked with. So I'm going to ask each of the speakers to introduce themselves firstly, and then Francisco's kindly going to give us an introduction to what AI actually is, because we've got quite a wide range of viewers from different seniorities and backgrounds here today. And then we'll dive into the questions and get the speakers' thoughts and ideas moving forwards. So yeah, firstly, Charles, maybe you could briefly introduce yourself.
Sure. Hi, everyone. I'm Charles. I'm the tech co-founder of Bunch.ai. We're a startup based in Berlin. We work mostly with psychology, data, and machine learning. And basically what we do is we use a lot of research from Stanford and other universities, bring their research in psychology into products that people can use on the market, either to help them make better hire in less time or build better teams using company culture. And we enable this by automating assessments using machine learning algorithms so that we can predict the same things without having people to go through a 1-hour assessment.
Great. And Francisco, maybe a brief introduction to yourself initially.
Sure. Yeah, my name is Francisco. I'm a front-end developer located in Zurich. I work for a financial company called Move Digital. Yeah, basically that's what I do. I do front-end, and I'm very passionate about machine learning, and I guess that's the reason why I have been invited to this talk. That's pretty much me.
Cool. So yeah, I think, Francisco, you mentioned you wanted to give a short introduction to what AI actually is, and I think that would be really interesting for some of our listeners. So maybe you could go straight into that.
All right. Yeah, no, it's I would like to explain a bit or clarify the terms AI, machine learning, deep learning, neural network, because they have become today like a buzzword. In some cases, they are used to advertise or selling points. They are purely for marketing. And you put blockchain and AI together today, and success is guaranteed. They are used. I can see that they are used interchangeably sometimes to explain technologies behind the product. Even though I have no reasons to doubt about this product, the problems they solve, how they solve it. I do have doubts about their limitations, which is not very clear based on using this word. So I would like to give like a few to explain a bit these terms. Let's start with artificial intelligence. I found this nice definition, which is, well, it's a branch of computer science concerned with the development of computers to perform tasks that require intelligence. Tasks requiring intelligence, well, they are generally considered to include problem solving, learning through experience, or automatically adapting to new scenarios. It's a very broad and vague definition, right? Like, think about a calculator. A calculator was considered to be an amazing machine, able to do something that only the human brain could do, which is perform complex calculations. Well, that's AI, right? If you see the problem of using these terms to sell a product. I mean, basically, any electronic thing nowadays uses AI. My oven at home, you can choose from a list of food you want to heat up or bake, and it will do it intelligently enough to do it right. So my oven is powered by AI. Another thing is machine learning. Machine learning is this is a technology that falls under the umbrella of AI. It's the study of computer algorithms that are able to learn and improve through experience. Basically, machine learning at its core is nothing more than a pattern finder. And it does this by feeding the algorithm with a lot of data. So we have different type of machine learning. I would like to mention, which is supervised learning, unsupervised learning, and then there is also there is semi-supervised learning, and then there are these cool algorithms called reinforcement learning. So supervised learning is these algorithms are fed with label data, so data with features and a target label, and then they learn to map an input to an output based on this data. So, for example, you have a list of fruit with the features like the color, the shape, texture of the skin, and then you have the target label that tells you the kind of fruit it is, like, for example, apple, banana, whatever. And so you give it a new fruit, but without the label, and the algorithm will tell you, based on this feature, what kind of fruits we are looking at in here. Then we have the unsupervised learning algorithms. These are fed with data without label, and they will try to find patterns, groups, cluster on this data, and then it's up to you to interpret this label. For example, there is this typical problem, which is the customer segmentation. You try to find groups in here based on customer features and spending behavior, and you try to find these groups to be able to target properly these groups. And then we have semi-supervised learning, which is a combination of these two. So you use unsupervised learning algorithms to find groups, and then you find these groups, and you use this group as a target label. Then you train a supervised learning algorithm with the new target label, and then when a new data comes in, this algorithm will tell you in which group it belongs to. And then we have these very cool algorithms, the reinforcement learning algorithms. I think these are the real deal. These ones with the deep learning algorithms, they are the real deal. This is what I say. This is the proper AI. Anyway, this unlike the other algorithms that need they learn from data. This one you don't pass data. What you do is basically you pass an environment, a set of actions, rules, constraints, and it will it's just to know what's possible to do or not and how, and the algorithm will learn by trial and error. Now, how does it know that it succeeded or failed? There is always this some sort of reward in the shape of something good to maximize or something bad to minimize. And then we have artificial neural networks and deep learning. These two are also used interchangeably sometimes, but we need to make a distinction here. Artificial neural networks are inspired by biological neural networks. That doesn't mean that this is how our brains work. I mean, we are guessing here. We are just trying to mimic how our neurons are interconnected, what they do inside, how they pass information to each other. They are very, very old algorithms. I mean, they were invented, I don't know, like in 1940 or something like that. I cannot remember, but they had a big push in the 80s. 80s and beginning of 90s, but their popularity diminished because they had issues mostly related to lack of data and computational power to train them. Today that's not a problem. We have a ton of data. We have really fast computers. This is how deep learning is born. So let me explain. So artificial neural networks are based on layers. you have the input layers. This is where the data goes in. The hidden layers, they do some computation, and then they have the output layer. This is the prediction, right? So deep learning uses very deep neural networks. Today we have a lot of different architecture, different deep learning architectures to solve different problems like convolutional neural network, or computer vision, for face recognition, object detection, and things like that. We have recurrent neural networks for natural language processing, voice recognition, machine translation. They solve this problem, or any sequential data. And then we have many other residual networks, autoencoders, generative adversarial networks. This last one is very cool because they create very realistic things. Anyway, so basically, this is the difference between these terms and how they are connected. So deep learning is a machine learning algorithm that uses very deep neural networks. And then machine learning is a subset of artificial intelligence. Now, the reason why they became so popular today is mainly because of the advances in deep learning, and also because we have a lot of data now, very fast computers. So we can see very cool stuff like autonomous driving cars, face recognition, a virtual assistant like Alexa or Siri, chatbots, or Google DeepMind with its AlphaZero that is able to beat Go and chess master. So yeah, that's basically that could be an introduction. So we can continue now and talk about front-end and where AI fits in here.
Great. Yeah, I mean, that's a really good introduction and really good to get some kind of clarity on the terms. I guess particularly interesting for those that are purely front-end developers and haven't really looked into artificial intelligence so far. So thanks for that. But yeah, now I'd quite like to firstly speak about the kind of main question to Charles, I guess, to get your kind of initial thoughts really on whether it's possible for artificial intelligence and whether you think it will happen that artificial intelligence will replace front-end developers.
So it's interesting. A couple of things going around lately. Projects that automate from drawing on the board to generating code. These are interesting scenarios for companies that would like to prototype very quickly something and bring it to the market. I think it mostly comes down to the quality of the code that it generates, but the biggest issues I would see with it would be the maintenance and the evolution of this code that is generated, and how would this workflow go within the team. But mostly coming from the feedback I have building an AI company, what we've seen is where the market usually sees the most value in AI or machine learning is when it augments or optimize something that people already do in ways that they cannot otherwise. Whereas when it tends to replace something that is not a task that is boring or to be automated, people usually have a lot of trust issues with the said system, and then the market adoption is very tricky in this case. So from what I see, I see two different kind of use cases. One where it could replace front-end developers in some tasks that are very specific, like optimizing the time between a prototype and an actual UI being built, which could enable better user testing for designers, for example. And on the other hand, I can also see where completely replacing front-end developers, the biggest issue with this would be how to actually bring such a product to the market. Whereas if an AI system is used to optimize the job of a front-end engineer, then it might actually be easier to adopt. And there are things that are coming out. So if you look at the analytics space, a lot of them are today bringing persona, which is basically using some of these unsupervised algorithms to do clustering of users on a product to better understand what is their behavior. And the ability to do that on the front end and actually have an adaptive front end, depending on which is the persona using it, could actually enable businesses to optimize for a specific use case and actually have different front ends running side by side and reacting to how the people are using it. So actually using AI to enhance and customize the experience of users. And this is something that cannot be done. It can be done by having front-end engineers working on it and really understanding the personas, but it would take a lot of work to actually have this fully automated. So this would be some of the applications I see on the top of my head where AI could be useful and AI could not necessarily replace front-end engineers, but maybe make them more efficient or make designers more efficient and moving something from a whiteboard to a prototype.
Okay. Sorry, Charles, I think we lost the microphone there for a second. I'm not sure we can still hear you, but yeah, that's really interesting, actually, how the idea that it can enhance the user experience. I think a lot of people are approaching this topic from the idea that, you know, they're just going to replace their day-to-day work or make parts of the actual development process easier. But to hear that there's applications where it can completely change the way someone interacts with a web page depending on their personality, that is really interesting and definitely quite exciting. Yeah, I guess I'm quite interested to hear your kind of initial thoughts on the question as well, Francisco.
Can you hear me?
Yes, I can hear you fine.
Perfect. Okay. Well, before answering the question, I would like to just take a closer look at what front-end development is about. So maybe we could have a better idea whether AI could replace it altogether, part of it, or be a tool to enhance it. So front-end comprises three main technologies, right? HTML, CSS, and JavaScript. And everything else, framework libraries, preprocessor, post-processor, blah, 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 builders, bundlers, and compilers, and a long, etc. of stuff are just built around them. I mean, the point is at the end, this is going to run in the browser or any other platform that has an interpreter and understand this technology. So these are the three main building blocks. You use JavaScript to develop the business logic, HTML and CSS, you build the UI, right? So let's have a look at the business logic. I mean, in this case, the question would be: could AI replace software developers? I mean, can AI write code? I read about a few experiments. I mean, there are some attempts out there. There's this guy called I have it written down here, Andrei Karpathy. I don't know if I'm pronouncing the name right, but he's the director of AI at Tesla. So this guy trained a multi-layer recurrent neural network using the entire GitHub Linux repository. I mean, I'm talking about like 500 megabytes of source code. And he let it run over the night. And next day, he got a few functions spat out by the model, and actually very good looking functions with everything in place: parameters, variables, condition, loops, proper indentation, curly brackets in place. Even the function had a comment. It had a few mistakes, like declare variable were never used, variables were never declared, pointless conditions like comparing a variable to itself. But overall, the code was quite good. It didn't do anything useful though, but the guy was very, very satisfied. This project is in GitHub. I might post the link. There's also this program from Google, and as far as I read, was from Google and Cambridge University. It's called Deep Coder. This program is able to write code and learn, and you feed it with a small description of the problem, and it will write a few lines of code, try to solve this problem. It has limitations. I think I read something like it only can write 5 lines of code or something like that. So it is actually a very big limitation. There are other attempts and experiments, but they all come with a huge limitation and definitely not reliable enough to write production worthy code. Now, software development is a complex task. It requires a good understanding of the problem and the business. It requires intuition. Machines are very good at finding patterns, and we have definitely no chance at all of competing against machines in frequent high volume tasks. But when it comes to solving a problem that hasn't been seen before, machines really suck at it. I don't think it will happen anytime soon that machines develop intuition and the ability to interpret business values of features. I mean, machines will definitely write code one day. How reliable this code will be? Well, not even professional software developer writes reliable code. And let's not forget that machines will take our code as a reference. It will definitely help us a lot with our workflow. The way I see it is more like a coding partner, like an assistant. And it will help us to optimize code review, finding bugs. Like you feed a machine. I mean, with the right architecture, you feed a machine with let's say the entire GitHub, not only source code, but also issues, commits, reviews, fixes, and this machine will be able to tell you where, with high accuracy, where there's a potential bug, bugs that no compiler, linter, unit test will be able to find. Actually, this is not an idea. This is already done. There's another program called Deep Code, not Deep Coder. This application I mentioned from Microsoft. This one is called Deep Code. Check it out. It's amazing. And then we have the UI part. Could artificial intelligence build the UI? I mean, I think in here we have a similar situation to coding the business logic, translating business requirements and user interaction into HTML and CSS. That's not an easy task to automate. I don't think it will happen anytime soon. Now, what we can do today and will probably improve a lot in the next few years is creating UI based on images and handwritten sketches. This will definitely speed up the design workflow. Like, for example, Airbnb is already using machine learning to make this process more efficient. They have created this internal tool that's able to write HTML based on drawings. And Microsoft also, they have an application called Sketch to Code. This one is very cool because it's the same. You feed the machine with sketches, handwritten sketches, wireframes, and it'll be able to detect typical HTML elements like buttons, labels, drop downs, checkboxes, radio buttons. It also understands handwritten text. And the coolest thing is that it recognizes layouts. So it's able to build this HTML, placing the right elements in the right position. This is definitely a very cool tool to create prototypes in the browser, and you can use it also as a scaffolding to build applications. There is another one. It's called Pix to Code. This one basically it uses the screenshots of graphical user interfaces to generate HTML and CSS. And now one could imagine crawling the World Wide Web, collecting a data set of HTML and CSS and the associated screenshots of the render page. I mean, I'm talking about using the whole internet as a supplier of training data for deep learning methods to fully automate the implementation of UIs. But with all these tools, there is always a problem, which is they are fed with the static images. There are no moving bits, no animation, no effects or transitions. They don't tell anything about about user interactions. So what should happen when the user clicks here or there? This part will have to still be implemented by humans, I would say. Maybe a combination of screenshots or drawings plus a small description of the UI could be enough for the machine to add this code to implement this part. But yeah, That's basically my opinion.
Okay, so kind of quite similar in some ways, I guess, where you're seeing the main kind of benefits at the moment in the kind of short term, definitely in the prototyping stage, getting maybe landing pages from sketches and things like that. So I'm not sure, like either of you, what are the kind of the main technical limitations when we're looking at kind of building reactive interfaces and user experiences? What are the kind of main challenges that would have to be overcome before this becomes a reality? Charles, do you have any thoughts on that?
Currently, if you look at the way it's done, when you have tools like, if you take, for example, Sketch and Zeppelin, which tries to streamline a bit the transition between a designer's work and a front end implementing the design by sharing a common style guide and generating some of the code or some of the CSS that needs to be used. The way these tools work is they usually rely on an abstraction layer, which is called a domain-specific language, that enables to specify the UI using visual elements that are commonly known, like a checkbox, radio buttons, and so on. The way we usually interact with this DSL is either with a graphical user interface or by writing directly that DSL, where you could actually specify, I want a layout, and this layout I want a grid, and so on. So you can have this writing a grid instead of writing the actual HTML that would be generated by it. Where it could be interesting is actually using AI to turn this domain-specific language into a natural specific domain language, where, for example, a business person could express in terms of business what they want to achieve and what they would expect the application to look like or to do, and then the AI would actually be interpreting the input of the user into a domain-specific language that can then be used to generate code in a very accurate and predictable way that the developer could then take on. So the way we mostly use DSL is limited, and people need to have a sort of an intrinsic knowledge about how to use Sketch, for example, or how to use this very specific DSL. And this limitation, this limits the amount of people who can interact with these tools that can then be used to generate code. AI can actually help in this case by making it more accessible, by being able to understand what are the needs that people want or what they want to achieve, and then translate that into a DSL that the machine can use to generate code afterwards.
Great. Okay. So yeah, I mean, coming on to that point then, I guess. So I guess we're not going to see AI replace developers anytime soon. But I guess even based on what you said there's still going to be ways that developers can maybe change their mindset or start preparing so they really effectively use these tools as they become available and maybe implement AI into the development process a bit more. So maybe, Francisco, do you have any thoughts on what developers should be doing now to prepare for more of an impact when AI becomes more used in development?
Well, as we have seen, AI will help us in our workflow, at least in the next few years. Business logic will still take some time to be automated, unless this is all shifted back to the backend and frontend is just about static pages like they used to be. Then it could be a matter of years until frontend is no longer coded by humans. I mean, I'd say we keep on doing what as a front end you've been doing so far in this crazy front end world, which is staying up to date with the latest technologies, so as not to become a dinosaur, which in front end happens rather quickly. The pace at which it evolves is sometimes scary. AI and all the technologies around it seem to be also evolving fast, and AI is about automating things. I'd say we'd rather keep an eye on them and make sure that we are also up to date with the tools that comes out to help to build the front end. It wouldn't be a bad idea to actually learn about machine learning and deep learning. There is this interesting library called TensorFlow.js. I used it in a few personal projects already. You can use it to import models built and trained outside the browser, but also build them and train them right in the browser. And the cool thing is that you can use the user GPU. Now, why would you need machine learning models in the browser instead of in the server side? Well, there are a few reasons why you want to do this. GDPR friendly. I mean, data never leaves the browser. There is no need to send any data to the server, providing with better user experience. Like, imagine the browser. The browser have access to all kind of sensors today and user inputs. I mean, webcam, microphone, accelerometer, device orientation. I mean, it's a great source of user input to play with. Think about this. You could basically interact with a website using just gesture. You could do that today thanks to this library. I mean, maybe there is no use case for that, but I mean, it's something it's possible to do. Also, something cool about using machine learning in the browser is that you don't need to using this library TensorFlow.js is that you don't need to install like heavy libraries, framework, compiler, interpreters, drivers. I mean, it's all already in the browser. So yeah, I mean, I guess front-end developers just they should keep an eye on how this is evolving, and yeah, but it's being always part of our job to be up to date with all these things. Otherwise, like I said, you become a dinosaur and you are replaced quickly.
Great, and yeah, really interesting that you mentioned TensorFlow.js there. Actually, that is actually, we're in talks at the moment to speak with another JavaScript expert who's also going to be presenting for us some examples of his work with TensorFlow.js. So that's something to keep an eye out on. It's going to be a future webinar topic of ours. And again, interesting how you kind of pointed out the ways we interact with the browser and how AI could potentially help us react to that. So Charles, do you have any ideas on what developers could be doing now to prepare for AI and maybe better utilize the tools that are already available?
Yeah, sure. JS is definitely interesting because it actually enables new workflows where, for example, a front-end engineer could interact with a data scientist, which doesn't happen quite often today. But if you look at a use case where a data scientist could actually use all the analytics that a company is collecting over the user base, you could actually build a persona classifier for your users, where you could have a user fall in a specific persona that has a different journey in the product. Some people might use it to accomplish one task, and another persona might have another task that they want to use. Where this is actually interesting is you could train a generic TensorFlow model in your backend and then deploy it in the front end. And then in the front end, you could actually fine-tune the model to fit that specific person and use it to optimize the journey. For example, you could switch a CTA from being secondary to primary so that the user is more easily locating the action that they need to perform so that they get their job done faster. But what this requires in terms of if I'm a front-end engineer and I want to start working on these scenarios, which are already possible today with TensorFlow, the part that is missing, I would say, would be the data literacy, meaning a front-end engineer needs to be able to communicate with the data scientist, and they usually have a language that is very different, and you need to understand what is very simple things like a distribution, and what is accuracy, because depending on the problems that you're trying to solve, accuracy might be better expressed with like the actual accuracy of the F score or the loss or the recall. And then understanding what these terms mean is actually very important when designing the experience, to understand what would be the risk of classifying someone in a wrong persona, and yeah, understanding all these things. So getting a bit up to speed on data literacy and being able to communicate with data scientists and bridging the gap so that they can both interact directly could actually help front-end engineers make use of these machine learning technologies that you can train on a large scale in the backend, and then optimize and tailor to the users in order to deliver a better experience for them. And TensorFlow is the technological bridge that allows to reuse the same models in the backend and in the frontend. But for that to happen, the front-end engineer might need to be able to understand how these things work.
Okay, so if a front-end developer, does want to become more data literate, start understanding these technologies, be able to communicate better with data scientists, could you recommend anywhere for them to start? Any good sources of information, anywhere that you would recommend?
Yes, there's one that is definitely a course that I would recommend to any person who has a technical background. It's called Machine Learning on Coursera from Andrew Ng. It's a very good course to get first hands-on and intuition in terms of what is machine learning. It doesn't necessarily use the latest tools, as in doesn't necessarily use Jupyter to do experimentations and so on. But the course in itself has a very good quality and a very intuitive way of learning the concepts of machine learning that are used in many of the algorithms that we see today. And then there are a lot of content on GitHub in the awesome curated list. You can find a collection of Jupyter Notebook, which is basically an environment where you can document, run code, and visualize the outputs. And that is a very good way to experiment with machine learning, because you can very easily modify the code and see different results and experiment with it. So to summarize, the machine learning course from Andrew Ng on Coursera, to really get the theory and the basics of machine learning, and then playing around with some Jupyter notebooks to actually get hands-on experience and starting to practice it.
Great. Okay, that's brilliant. That's really some good kind of practical and useful places. And what we will do is collate this information after the webinar, and we can send this out to people. So yeah, I mean, that's been really interesting. We've got some great kind of insights into possible uses, limitations, and also some really good things for people to check out. As I say, we'll collate these links afterwards to share it with the network. I guess now I'm just interested to hear, does either of you have any kind of final thoughts, anything we've not mentioned so far, maybe any uses which could come further down the line that you think are exciting? Just any final comments that maybe we've not covered so far, really. Start with you, Francisco. Anything else you would like to add at the moment?
Yeah, I actually wanted to talk about some two methods in machine learning that could help us to create amazing websites, and because we could pre-build website based on a lot of training data, right? Like I mentioned before, we could do something. We could, like I said, pre-build this website, or we could do something super cool. I am actually looking into lately, which is using. We could build a website that come to life, because there are these two methods in machine learning called online machine learning, and there is also this algorithm in reinforcement learning called it has a very cool name. It's called multi-arm bandit algorithm. So let me explain this. Let me explain how this is possible. there is this an online machine learning. It's about constantly training the algorithm with new data, right? Think about users interacting with a website where they click on what they buy, etc. And this algorithm is constantly learning based on this behavior, so it'll pick up changes. Unlike the other algorithms that are trained with a lot of data, but once they are trained, that's it. It'll make predictions based on that data. We might be missing out valuable information new data could provide. And then that's with online machine learning. And there's this multi-arm bandit algorithm. This is very cool. It's similar to A/B testing, but better. Like A/B testing is about presenting randomly different solutions to the user, right? You do this exploration, and it means you explore long enough until based on whatever metric you decide certain solution is the most successful one, and this is the one you stick to forever. And then you have this algorithm, multi-R bandit algorithm. It does the same, but it combines it with exploitation. So basically, it will try to find the most successful one so far, and then present it to the user most frequently. But still, it will keep on exploring and exploiting the other ones, and it might happen that this trend changes, and then another one becomes more successful. Then the machine will shift the preference towards this one. So basically, it's like I said at the beginning, it's like building a website that is alive. And it will just change, will keep on changing depending on the user preferences, how they interact with the website, depending on maybe something happens, and for example, in online shops selling clothes, maybe something is more fashionable now, and then people start buying these. So imagine the layout of this website might change depending on this. This is something I'm exploring right now. I find it very interesting. Yeah.
Great. Yeah, that's really interesting. So that, I guess, is where we really start to see the possibility that AI can push development somewhere that a normal human can't do or can't keep reacting to in that way. Great. Okay. And Charles, do you have any kind of final other things you'd like to mention, or could be kind of discussed further if you like?
Yeah, sure. So definitely, I think that in a couple of years, websites will be a lot more adaptable, and will be to understand the personality and the emotions that users have when they interact with it, and then adapt to these emotions to deliver either a better experience, but also from a business perspective, optimize conversion rate to different funnels. Because in the end, if a company is using X or Y technology, there should be a reasoning behind it. It shouldn't just be because AI is cool. So there's definitely one of the paths, I think, where technology will go, because that's one very clear return on investment for a company that would deploy this in their front end. On the other hand, I know there is a problem that is very frequent and that is still not solved today, and it's the problem of software estimates and predicting bugs and risk. And I think that machine learning could actually be very useful in that way, in helping, not necessarily replacing estimates, but providing additional data points so that software engineers could make more informed decisions to estimate a user story, for example, based on different things. If we are able to actually map how much code needs to be built for a user story, and understand this in the context of this company or this team that is building this product. Again, it's about tailoring and customizing it to the context of who is using the algorithm. It could actually help people and better how to estimate. And beyond estimates, the ability to predict the impact on maintainability of the code if we do X or Y feature. For example, adding complexity usually makes it harder to maintain or evolve the code. And at the same time, algorithms could also very well predict the likeliness of X or Y feature introducing new bugs or regressions in the code base. And these, I think, are very maybe less interesting problems or less attractive, but they are very real in everyday life of most developers. And anything that could actually bring more data points to make more informed decisions could actually help most businesses and most developers achieve more, because it could be more predictable, and that usually ends up in better plan, less cut on UX because we don't have the time to finish the feature. So yeah, this is also an area where I see AI could be playing a big role.
Great. Okay. Yeah, that's really interesting. I think what's really come to light in this conversation, when we first put this topic out there to our networks, we saw a lot of response saying AI will never replace front end. What this conversation has brought to light is many different ideas on where it could go in future to help developers. I don't see a future where front-end developers aren't going to have a job, but what I do see is that AI is going to allow them to create even better user experiences and maybe have more time to explore other parts in their development process. So really interesting. As I say, I'm going to collate some of the things that we've discussed there. So the course links that Charles mentioned, also the tools that Francisco discussed, and the TensorFlow.js links. So yeah, I mean, I hope that was interesting for everyone. Charles and Francisco, thanks very much for your time. Really appreciate you spending the time doing that. Obviously, check out Bunch.ai. Check out their product. I know they're hiring as well, so have a look at their page. And yeah, we will share the links from the speakers and this content as well. And hopefully there's something that you can take away and learn from this. So speakers, thanks very much for your time.
Thank you, Joe. Francisco, and thank you to everyone who attended.
Perfect. Cheers.
Cheers.